For number 5, A through D, we are going to be simplifying the radical. So for 300, we could break that down to 10 and 30. And we can further break down 10 to 2 and 5, and 30 to 5 and 6. 6 can break down to 2 and 3. So we look at the end of our branches, and we have 2 2s, a 3, and 2 5s. So this would give us a pair of 2s and a pair of 5s. Our pairs go on the outside of the radical. We take 1 2 from here, 1 5 from here, and we multiply those together. The leftover 3 goes on the inside of the radical. Letter B, we have 2 perfect squares. So the square root of 25 is just 5. The square root of 81 is just 9. 5/9 cannot reduce, so that is my solution. For letter C, the square root of 144 is a perfect square, which is 12. But 20 is not a perfect square, so we can break it down to 4 and 5. And the 4 can break down to 2 and 2. So we have a pair of 2s here with the leftover 5. So 2 radical 5. But as we discussed in class, the 2 and 12 are considered like terms, so we can reduce those by 2. So that would be 1 and 6. You don't have to write the 1. You can if you want. So we have the square root of 5 over 6. Okay, and then lastly, for letter D, 40 is not a perfect square, so we break it down. You could use 4 and 10 or 5 and 8. Okay, 4 would break down to 2 and 2. And 10 would be 2 and 5. Here I've got a pair of 2s. So that would go on the outside of the radical. And the leftover 2 times 5 would be multiplied to be 10 and go on the inside. But we see that we have 6 x's here. So I list them. I find all my pairs, which is 3 pairs of x's, so I've got x cubed. So my solution is 2x to the third square root 10.